What up, people? Gonna work through this study guide as quickly as I can to show you how quickly these things can be completed as you continue your mastery of this subject and these ideas. The ideas are the same in all of them, even though you sometimes see them as different. We're gonna find out how we can do these problems quickly. I'll explain some things as I go, but I'll leave some things out. So let's start. Square root, that means conjugate, so I'm going to get 9 minus x plus 6 in the top, which is going to give me a negative x plus 3, which I'm going to factor to give me a negative x minus 3, which is good because in the bottom I have a 2x minus 6, which is an x minus 3 with a 2 out front. So I have a whole that cancels, so I'm left with a negative 1 over 2 times that conjugate, which is 3 plus root x plus 6. If I plug in 3, I get 3 plus 6 is 9, square root of 9 is 3, 3 plus 3 is 6, 6 times 2 is 12, so my answer is negative 1/12. Alright, next problem. Fractions, common denominator. So I'm going to get 3 times 2 is 6, plus 2 times x minus 3 is 2x minus 6. The 6's are gone. I'm left with a 2x, which is going to cancel with that x, so I have a 2 over the common denominator, 3 times x minus 3, plug in 0. 3 times negative 3 is negative 9. 2 over negative 9 is negative 2/9, my answer. Next problem, x cubed minus 8. It is a difference of cubes, so factor it. I'm going to have an x minus 2 in there. I'm going to be left with x squared plus 2x plus 4. That will work out the same way every time you do difference of cubes. In the bottom, 5 times x minus 2. So my x minus 2's are gone, and I'm left with x squared plus 2x plus 4 over 5. Plug in 2. 2 squared 4. 2 times 4, 2 is 4, plus 4, so I have 4 times 3 in the top, which is 12 over 5, so 12/5 is that limit. Next one, sketch a graph. Absolute value, mama, over 2, boom, up there. It's been shifted up 1. That distance there is 3 because of that 3. So if I'm coming from the right, I'm up there on that branch, which is at 4. This one, again, sketch a graph. X-intercept at 1, 2, 3. Vertical asymptote at 4. Right there. Horizontal asymptote at 1. Sketch it in. It's got to look like that. Coming from the right, it is infinity. Again, sketch it. X-intercept there. Difference of squares. Boom, boom, boom. Boom, boom, boom. Positive 2 and negative 2 in the bottom there. Look, it's going to be positive over there because that's where the positive world lies. So this mean has to be down, so the limit is negative infinity. Alright, find the instantaneous slope of the function, which means we need to write the slope, which is going to be my function 3 times x minus 4 squared plus 2 minus the y value of my point, which I don't know yet, but I know the x value is 2, so x minus 2 in the bottom. Plug in 2 to the top. 2 minus 4 is negative 2 squared is positive 4 times 3 is 12 plus 2 is 14. So I have that. Expand the top. X minus 4 squared is x squared minus 8x plus 16. I'm distributing a 3, so I get a 3x squared minus 24x plus 48 minus 14 and plus a 2, so really a minus 12 is going to give me 3x squared minus 24x. 48 minus 12 is going to give me 36. So I can synthetically divide out the x minus 2, which means I have a 2, 3, negative 24, and 36. So do it real quick. 3, 6, negative 18. And look, we get 36, so that's gone. So we get 3 minus 18, so 3x minus 18. The x value is 2. 3 times 2 is 6, minus 18 gives us negative 12 for the instantaneous slope. Sketch graph of the function satisfies all those things. Limit as x approaches 4 is 0, 1, 2, 3, 4. There's a 0. X approaches negative 1 from the right is infinity, so I have to have an asymptote there, and I have to be coming down like that. That should be a 0 right there. Boom. So I'm going to hit that 0. Limit as x approaches infinity is 5, so this thing should probably come back up to 5. So maybe that's the y value of 5 right there. That goes up. That should probably be up as well. Limit as x approaches 3 exists, but f of 3 does not exist. Means we have a hole there. So how do we do it? We got a hole at 3, so x minus 3 over x minus 3. We got a horizontal asymptote at 5, so there's that. We have an x-intercept at 4, x minus 4. It bounces. Square it. On the left, negative 1, x plus 1. Tails go together, so squared. There we have our function. Number 9, calculator problem. Limit as x approaches infinity. 300 divided by 2 is 150. Limit to the left, 0. It looks like that. Limit as we approach 0 is 300 divided by 2 plus 4 is 6. 300 divided by 6 is 50. Next problem. 3 times 2 is 6 over 5 is 6/5 plus 1 is 2 0.2 for that first limit. This thingy looks like digga 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 boo, digga 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 boo, so that limit does not exist. Find the value of n that makes a constant. Well, x squared minus 9 has a whole at x minus 3. We'll be left with an x plus 3. When you factor out the whole, plug in 3, you get 6. 6 has to equal 3m plus 1. So solve it, subtract 1. 5 equals 3m. Divide by 3, so m equals 5 thirds. 15, need to find the value of the constant j and k. Figure out what your x values are. X minus 1/2 less than or equal to 3/2. So x is less than or equal to 3/2 plus 1/2 is 4/2 is 2. Do the negative x minus 1/2 is greater than or equal to negative 3/2. Add the 1/2 over. Negative 3/2 plus 1/2 is negative 2/2. Negative 2/2 is negative 1. So x is greater than or equal to negative 1. So our x values are 2 and negative 1. So negative j plus 2k has to equal 2 minus 4. So negative j plus 2k has to equal negative 2. Do the same thing with the other x values. So instead of negative j, now we have a x value of 2. So 2j plus 2k equals, substituted in. So 2 squared is 4 times 2 is 8 minus 4 is 4. Solve this system. Negative 2k equals j minus 2. 2k equals 4 minus 2j. Set them equal to each other. J minus 2 equals 4 minus 2j. Add 2j to both sides. 3j equals add 2. 6. J equals 2. We know j. Find k. So 2k equals 2 minus 2 is 0. So k equals 0. Last problem. Find the limits as x approaches negative 3. Where's negative 3? 1, 2, 3. Boom, going up to infinity. Negative 2 from the right. Negative 2 from the right is right there, going to negative 1. 0, we have an x-intercept at 0. X approaches 4. 1, 2, 3, 4. It's different from the left to the right, so it does not exist. Negative 2 from the left is going up there to that hole, which is at 3. Negative 2, different from the right and left, so it does not exist. As x approaches 2, we're going up to that hole, which is at 2, and as x approaches 6, we're going to that spot right there, which is also at 2. So it's now been 7 minutes and 30 seconds exactly, which means we just completed this in 7 minutes. So it is absolutely, absolutely doable for you. You just need to get a little more comfortable with these problems. You can do them quickly. Come to office hours. You'll get this stuff. I promise you. They seem different. All these ideas are using the exact same concepts. It's just a matter of piecing it all together. See ya.